Hi, my name is Dakota Stewart. I'm a third year majoring in civil engineering, and today I will be discussing nuclear power in Wisconsin. Now, I want you to imagine powering the city of Madison with massive amounts of clean energy where the only byproduct is water. If that interests you, then I may have a proposition for you. As stated, nuclear power is an extremely clean, extremely powerful source of energy, actually having less of a carbon content than solar power. But there's one problem. According to a study from the University of Wisconsin-Stevens Point in 2015, Wisconsin homes used 72.41 trillion BTUs of electricity. Let me put that into perspective. That is equal to 601 million gallons of gas. Is that not much help? 601 million gallons of gas in a 2018 Honda Civic, which gets about 42 miles per gallon on the highway, much like the one shown below me, would be enough to drive around the Earth over 1 million times. All of that electricity is just from Wisconsin alone. And that's why Wisconsin is facing this problem, not having enough nuclear power. First, to talk about nuclear power, we should go back over how nuclear power actually works. Starting with the control rods, shown well in the provided image below me. These control rods, often made of uranium or another heavy metal, are put through a process called nuclear fission. Nuclear fission is the process in which a neutron is added to a heavy element, such as uranium or plutonium, and thus making it unstable and splitting it into two smaller atoms. This process releases huge amounts of energy as well as heat. Extremely pure and treated water is then used on those uranium rods, and the water is heated by the rods to a boil, in which the steam is produced. That steam is then routed through a steam line to power a steam turbine. And then the steam is cooled with water pulled from a nearby water source, and through condensation, the pure steam becomes water again, and the whole cycle restarts, with the only byproduct being the steam created from the coolant water pulled in from the nearby water source. This process produces massive amounts of energy at a very reliable rate. If I want to go over the problems Wisconsin has with nuclear power, I should go over what we currently have now. Currently in Wisconsin, we have 3 nuclear power plants. One in La Crosse, over by the Mississippi River. One in Kewaunee, up near Green Bay on Lake Michigan. And the last one being in Point Beach, just south of Kewaunee by a few miles. Of those 3, only the plant at Point Beach is operational, as the plant in Kewaunee was shut down in 2013, and the plant in La Crosse was permanently shut down in 1987. The Point Beach power plant was first announced in 1965, and started producing power in 1970, when it was first issued its operating license. It currently has 660 employees, and the owner of the plant plans to have it produce power at least until the 2050s, which is a massive amount of time for a nuclear power plant these days. And overall, it has helped produce huge amounts of power for the last 50 years. The power produced from this plant alone helps provide power to the Green Bay area, all the way down the coast to Milwaukee and its surrounding area. That means that one plant alone is helping to provide power for millions upon millions of people. To put that into numbers, that single plant alone produces around 14% of the total power in Wisconsin. Remember that Honda Civic from earlier? That single plant power produced, translated to gas, sends the fuel-efficient car over 140,000 times around the Earth. Nuclear power is one of the largest clean sources of energy on the planet. But if you want to talk about nuclear as a clean power source, you also have to bring up solar and wind as well, which are one of the most popular clean power sources in the world. The main problem with those, however, is the fact that they are not producing power 65 to 75% of the time. That means if the sun isn't shining, you aren't getting solar power. And if the wind isn't blowing, you're not getting wind power. And the rest of the time, you still need to be able to power your hospitals and homes and cities. And while batteries have gotten much better, they just will never be as good and efficient as the electrical grid we have now, which nuclear power is connected to. Because whenever you put energy into a battery and then take it out, you lose up to 40% of the power generated. Nuclear power, in contrast, can provide power around 93% of the time over a year. And this is shown well by the chart below me, with nuclear easily being the most reliable power by a long shot, even among other unclean energy sources. The roughly 7% of the time that it takes off is for refilling and maintenance. And even though solar and wind have been making massive, huge strides in terms of technology in the recent years, it only accounts for half of the amount of energy lost from closing nuclear power plants over the years. You also have to take in sheer space as well. And you may think nuclear power plants are huge. And solar and wind aren't nearly as big as the reactors themselves. You have to take into account the energy produced versus the size. According to energy.gov, the average nuclear reactor needs roughly 1 square mile of space to operate. And while that may seem like a lot, to produce the same amount of power, solar would need 75 times that space to produce the same amount of energy. Wind is extremely more, needing 360 times the amount of space to produce the same amount of energy as a nuclear power plant. So not only is nuclear power smaller and more reliable, but it's many times more compact than the other sources of clean energy as well. When it comes to nuclear power, however, there is one big problem that I'm sure everyone here is aware of, and it's that people really don't like it. When surveyed among people around the world, even oil turned out more popular than nuclear in a percentage approval rate. And I think there are 3 main reasons that people don't want it. There's the fear of the plant melting down and causing damage. There's the waste from them, and then there's the association with nuclear weapons. First to discuss is safety. When it comes to plants melting down and safety, it's hard to make plants safer than they already are. In terms of death, according to Lancet, one of the most respected medical journals on the planet, nuclear power is the safest form of reliable power in terms of death for the energy produced. That statistic is shown below. Even solar and wind are shown here below, with nuclear being multiples times safer than even those. Next to talk about is the waste. And the most interesting thing about nuclear waste is how little there actually is. It's one of the largest worries among people when nuclear power is discussed, and it isn't just dumped and forgotten. It just sits in containers much like the ones shown below and is just monitored. And while there are ideas for reactors that use the nuclear waste for fuel, the honest truth is that we don't quite know how to do that yet. And to create those reactors would be extremely expensive. And even though that they will be using the fuel, there will always be fuel left over. But to put the amount of nuclear waste there actually is in perspective, if you were to take all of the nuclear waste the US has ever produced from nuclear power plants, put it on a football field and stacked it, it would only be 20 feet tall. And while you still may think this is large, you just have to think about the sheer amounts of coal and oil we have used over the years as well. And finally, when it comes to nuclear weapons, I think that nuclear plants actually have the opposite effect. In fact, there are no recorded examples of a country that has adopted nuclear power and then produced a nuclear weapon. It always goes the opposite way. So if you want to rid the world of nuclear weapons, you take the plutonium from the warheads and use them for clean energy. And for that, you're going to want to start to build a lot more nuclear power plants. And who's to say that shouldn't start here? And that's why I'm asking for $7.5 billion to begin the construction of a modern nuclear power plant here in Wisconsin, which could help provide millions of people with clean, safe, and efficient power. I will now be open to any questions, comments, or concerns. Thank you.